Welcome for today's webinar about electrical clearance and creepage analysis. We will see the new version AutoCrear 3.0 with a new ECAD interface. My name is Urs Simler. I will guide through this webinar. First I will talk a little bit about the presenters, about Aveniq, then Michael is also in the call, Michael Martinek from e-laborate. He will talk a little bit about e-laborate and about the news in AutoCrear 3.0, and of course half an hour he will show us the news in a live demo. If you have any questions, feel free to ask your question due to the reasons of a huge number of participants use the question panel. First, some information about the presenters. This is me, Urs Simler, CAD simulation guy from Aveniq. In the call, I think he's not here. This is our sales guy. This is Daniel Losley from Aveniq. And the most important person for today, this is Michael Martinek from e-laborate. He's the founder of AutoCrear. Few words about Aveniq. Aveniq is a reseller of PTC, so we are selling PTC products. We have our own tools. We are doing some trainings with that Creo, Windchill, MetCAD products. And beside that, we are also working with other partners. One partner is CAESS. This is topology optimization. And a very important partner is e-laborate with the product AutoCrear for electrical clearance and creepage analysis. There are other products from other companies, and we have an own training center in Switzerland, and we are 9 people and we are quite experienced. So that's all from my side. I will hand over to Michael, and he will give us his information. Is now, I hope, sharing his computer. Yes, I can see it, and I think, Michael, you have to unmute yourself.
Okay, I hope I am.
Yes, great.
So thank you, Urs, for the introduction, and also thank you very much for hosting this meeting and organizing this webinar. A few words about Elaborate Innovations. We are developing software for clearance and creepage analysis. That's basically the only thing we do, but don't worry, it's keeping us busy enough. It was also requiring some preparation. We did 5 years of research before we could even start to develop the software, where we derived the math behind the creepage distance metric, where we developed new algorithms in order to be able to compute these paths. And after this, we brought these ideas into application by founding the company Elaborate Innovations, and just for the purpose of developing the software for industrial use. We have our standalone solution, AutoCrear, which is our flagship. It is applicable for any system. There is also a small brother of AutoCrear, CCX, which is a version of AutoCrear integrated in Creo, but due to technical limitations, we could only integrate a small subset of the AutoCrear features into Creo. So I think it's okay for smaller assemblies or individual parts, but in order to make a full analysis of an entire system, I would absolutely recommend to go with AutoCrear. Now we are still working on it, so there is more to come. We are working on new features and on performance optimizations with our full team of 8 people in the moment. And now we have reached a milestone with the version 3.0, which I would like to present today. If I need to explain the version 3.0 in one sentence, I would say it brings together the mechanics and the electronics for a combined analysis. This includes the ability to import PCBs and create a clean 3D model of it. Combining this data with the mechanics and taking all the information which is already defined in the board on the PCB directly into the 3D model, which is, for example, the grouping of nets, which can be automatically done in AutoCrear. Then we can specify different requirements for the different areas. On the board there is a different requirement than outside of it. We can also import requirements which, if you already have defined your board rules in your layout system, then there are dedicated file exchange formats which we can use to automatically define these requirements in AutoCrear. And last but not least, we can recognize each path we have computed by means of its context. So if we recognize if a path is outside of a board, we need the outer rule of the corresponding board requirement. If it's inside of the board in an interior layer, we know it's the inner rule, and so on. The first three of these features you might already know well from the current version of AutoCrear, where we have these features for a long time in a beta version. But the other three features could not be there because the architecture was not meant for that. We had to completely refactor our internal architecture to be able to define different requirements, and this is now the big novelty of the version 3.0. There are some other improvements as well, also for users which don't need PCBs, especially performance. Due to our massive refactoring of the internal architecture, the performance, especially for a large number of nets, is significantly better now. And there are also some other minor improvements for everyone, which I will present in a later slide, but let us first focus on the PCB interface. When we are talking about creepage on PCBs, you might argue that it's actually very easy to check them. Well, that's true as long as we are on a single layer. I mean, checks like these are easy. 2D methods are sufficient for that, and every layout tool can do these checks. That's no problem. But what about path on multiple layers, going over the border of a board or through a hole into another layer? What about conformal coating areas which have different requirements on the board? And especially, what about path between signals on the board and the surrounding mechanics? This is now possible in AutoCrear. We can incorporate everything in a single tool, so we have a full 3D representation of everything. There is our mechanics, and there is also a clean 3D model of our boards in it, and it's very easy to get this information. I will show this to you later in the live demo. And once we have established this, we can compute everything at once. We get our trivial paths between the copper traces on the boards. We get even the path over multiple layers. We get the path from the PCB to the surrounding mechanics. And of course, we still get our paths which are pure mechanical. And every single path is correctly assigned its requirement. Now, how can we get a 3D model of everything? Well, many of you might say, hey, I already have it. In my mechanical assembly, there is the boards already. That's not a big problem. You can get a step file of your board from any system, but that's only a very simplified representation of it. In almost all cases, there are no copper traces or pads on it. And if they are very, very, in a very bad geometric condition. Also, you lose all the metadata, which you already defined on your board. All your net groups and so on are lost in this data. You would have to reassign them, but you couldn't even assign them because there is no copper trace here. So this data does not help us. Also, geometric representation is not very good here. So the idea is to replace this by a complete representation of the board. And in AutoCrear we have a direct interface to a format called ODB++. That's an exchange format for boards, similar to STEP for mechanical data. So every layout system can export this format. And then we can import this in AutoCrear and we generate a clean 3D model out of it in two different ways. Either you can get a very simplified representation of the board in case you don't have any 3D models of your components which are placed on top and the bottom of the boards. And we can just extrude the footprints. The footprints we know from the ODB data. We also know a height from it. So we can make a very simple representation by just extruding this footprint by the height. But you can also establish a database in the background where you have all your components, and then during the import we can automatically place them into the correct positions, and then you have a perfect 3D image of your board with all the copper traces, with all the pads, with all the components, and everything is already assigned. The material and also the nets are already known. In order to get a database for this very nice import here, it's also very simple actually. You just need to organize two folders. One ECAD source folder where you just copy your step files of your components. Then you have to process them once into an AutoCrear format, assigning all the materials once, checking the orientation, and then your database is set up. And then you can use it automatically in the import, and we will place these components on the correct positions. And the best way to combine these boards with your mechanics is to keep the dummy representations of your boards in your mechanical assembly. So don't remove them all, just remove the components because they will come back from the database, but keep your board, because now you can use the replace function in AutoCrear where you replace this dummy by a PCB, then you import your ODB++, and we will replace it at the correct position. This is something I will show you later in the live demo, how easy this is. And after we have defined all the materials, in the next step of the workflow where we deal with electric nets, you will recognize that there is a lot of nets already defined because we know them from the ODB data. However, these nets are on the lowest level, and there might be thousands of logical nets on such a board. For the actual clearance and creepage analysis, you only need the groups of them. There is only a handful of net groups, and they are also defined in the layout. In some cases, it's also possible to have these groups directly exported into the ODB++, but not all systems support this. If not, still no problem. Every system has its dedicated files where we can find this grouping. So we can also import them afterwards, and then we do the grouping. So then you don't have your thousands of low-level nets, then you have your handful of net groups, an HV group, an LV group, and this is the level where you do the analysis later. And then in the next step, when we specify the requirements, this is now a big novelty. In the current version of AutoCrear, we could assign one value for creepage requirement. But as you can see here in the standard table, this is the IEC 6664, there is a special column for printed wiring material. That means that you can, you have much smaller requirements on the board than outside of the board, which is due to the solder mask, which is kind of a cover against a protection against pollution. So now let us assume we have a net pair with 500 volts. So there are a lot of different requirements here for this voltage. And the new level of the new hierarchy we have in the AutoCrear analysis tab is the context switch. There is always a mechanical context, which is everything outside of boards. In this mechanical context, you type in the values from this section of the table. We can also now distinguish between the different materials, so you can type in your requirement for material group 2, which is 3.6, and then we have another one for material group 3, which is 5. This is our mechanical rule, everything outside of board. But what about all boards? Now we can just switch the context. Every board we have imported in AutoCrear has an own context, and now we can enter different values for the same net pair. So we have HV plus to ground, which is, let's say, these 500 volts, and now we have a different column here for the context of the board. So for the same net pair HV plus to ground, we can now enter the inner rule of the board here and the outer rule of the board here, which is 1.3 and 2.5 in this example. And normally you don't even have to enter these values on the boards, because these values, these board rules already are defined in your layout system, where they are also checked with the simple 2D checks. So there is also possible exchange file formats where we can directly grab this information from. So it is also possible to import them from these files. And after we computed the paths, we can automatically detect the correct requirement. If we notice that a path is between two layers on a board, so inside of the board, then we know that we have to apply the inner rule, the 1.3 millimeters in this case. If a path is on the outside, we know automatically it's the outer rule, it's an outer path, so we need the 2.5 millimeters. And if it's outside of any board, then we recognize it and we know, okay, now we need the 5 millimeters. So there won't be any false positives anymore, which is the case currently, because we would check the worst case, but then you get a lot of violations on the other contexts where you can place the nets closer together. What about paths on multiple contexts? They will be assigned the highest requirement. Here is an example of a path which is partly on the outer side of the board, and then it jumps onto a bus bar. And as soon as a path leaves the board, it is a mechanical path for us, so it needs the mechanical requirement, the 5 millimeter in this case. Industry standards allow us in this case to rate the path segment-wise. This is still to come. For example, here, if this section of the path, which is on the outside of the board, if this section alone is meeting the outer rule of the board, the path will also be okay. But this will come in one of the next updates. And since we are now talking about things to come, let me also mention conformal coating here, because I'm pretty sure that this would be an answer question later in the Q&A. We get this a lot because it's something you also cannot check with current tools. The coating information, however, is not in a dedicated layer of the ODD stackup, but we have seen a lot of users who define their coating in a documentation layer. So the idea is that we can also import these doc layers, so you can decide which of these dock layers includes your coating, and then we can automatically generate a thin layer for this coating. So we cover everything which is below this coated area, and then we can automatically detect if a path is inside the coating or not, and then we can introduce a third column in the PCB context for coating. Then you can not only enter your inner and outer rules, but also maybe a different rule for the coated areas. So to be precise, this is still to come. It's not already in the 3.0. You probably see it, different fonts here. I faked this, but it will also be in the program in the near future. Then let's talk about some common improvements of the version 3.0, which are good for everyone, not only for users who want to work with PCBs. This you might have already seen in the previous slide, that we now have more than one column in the creepage section of the requirements. Every insulation class which is present on your assembly now has an own column where you can enter the corresponding requirement directly. It was possible before to define different requirements for the different installation class, but only with standard tables. Now it's also possible here with custom parameters to distinguish between different classes. We could do this because we saved some space by moving the growth width parameter to the global adjustments of a context. This is meaningful because the growth width parameter actually depends on the pollution degree only. So it's not depending on different voltage levels between the source target pairs. So it's normally not necessary to have different growth width parameters within a context. So it makes sense now to move this to the global section. You only have to enter it once. The only application, the only reason why you should change the growth width parameter individually for net pairs is this additional sentence. We know from very rare customers who are applying this, but if you want to apply this rule, which says that if the clearance is less than 3 millimeter, the growth width may be reduced to 1/3 of the clearance. And if you still want to apply this, it's even better in the new version because you don't have to calculate them and enter them manually. You just have to activate this option here. And then we will automatically take care of this option. Another common improvement is that we now have two different columns for voltage difference. If you are using standard tables, we map the voltage difference between the nets to the corresponding value, but we normally need two different voltages for clearance and for creepage, because clearance normally also needs to consider peak voltages. That was totally missing in the current version. So now we have these two voltage delta V columns. We also have two different columns for the maximum gallop, the get at least one path ranges. And we probably will also introduce different violation distances for clearance and for creepage, which is currently also just one global value. In the section where we visualize the results, we also made some significant improvements. For example, in the visualization of one single path, we can see the hidden sections of a path by dashed lines. It's also now possible to pick paths from the 3D window, much easier than it was before. We will draw, by default, we draw each path with a thin line, and the selected path will be drawn thick line, and you can pick them now directly from the graphics. You will see this in a few moments when we show a live demo of it. Also, paths get a unique ID in order to reference them globally. And we have revised the path filter. It was a horribly complex feature before. Now it's just a slider where you can change the level of detail. How many paths beside the globally shortest path will be visible. That's all about the slides. Now let's move over to a live demo. I prepared this small assembly, which is a mechanical part with some boards in it. And this is the dummy representation, which is normal in the pure mechanical CAD data. And now let's replace this by our import of PCB of ODB++. So we can use this replace function also on part level, which now would replace both or all of the occurrences of a board. Here, for example, is same board is referenced twice in this assembly, and we can replace it in one step. So we replace this by a PCB. Now we choose our ODB++ version of this board, which is this one. Then our ODB++ import mask opens, where you can see the stack up of the board. You can choose which layers you want to import. In this case, let's import everything, and the components, let's take them from the database. So in the detailed version, now we still have to match the footprint of the board to a model in our database. This can be done by name matching or by files. In Altium, you can, for example, use the native PCB doc file of Altium, which includes this mapping. And then we replaced this dummy board by our very nice 3D representation of this board, and everything is already prepared for the next steps. You see the materials are set, coppers are there, the traces are there, and all the components are placed at the correct position. Now we do the same for this board. Let's replace it. This is a different board. This one. Now the same mask again. Again, we want to have our detailed version of the components. And now with a few clicks we have replaced our dummy boards by the perfect 3D image of them. Now we also have to define the materials. Now for the mechanics, that's no problem. Let's say this is insulating and these parts are conductive. So we are already finished. We can go on to the next step, where we now see that electric nets are already present with the original net names. We also recognize the connectivity to mechanical objects. So we know that this net P1 is connected with this pin here, and despite the fact that the pin is actually a mechanical object with no net information, it now also was assigned to this net because we recognized this connection. I have some gaps here that should be connected, so let me correct this by a manual merge step. And also let's ignore the voltage for now. We now working without voltage for this demonstration. And now we want to group the nets, because this is the lowest level of nets. We don't need this level for the analysis. The group information is also defined in our layout, but in this case it was not directly embedded in the ODB++ file, but we can now bring it back, or we can bring it into AutoCrear by means of certain exchange files. In this case I have an Altium board, and we can also find the grouping information in the native PCB doc file of Altium. So this one, and then we have to decide which of the boards is this file belonging to. It's this one. And now there is some grouping. The rest is from the other two boards, which are both incorporated in this file. So this holds for these two boards. And now you see all our nets have been automatically grouped. And this is the level where we do the computation. How we apply this. And now there's also a small novelty here that we have configuration wizard before we go into the analysis tab. For the mechanical context, we can choose a standard table here, or we can choose to use custom parameters. For the boards, we can specify a file which holds the rules of the board, the inner and outer rules. Each different ECAD system has its own files. If you don't have any files, you choose manual input, then we can directly input the values later. For one of these boards, I have an example from Zucken. It's for the CSB board. Here I have requirements in an MTX file. So let's choose it, and now let's go on. And this is now the new version of the analysis tab with this context switch here. This is the mechanical context where we type in our clearance requirements and the creepage requirements between each net pair. So these are the rules which apply for areas outside of any boards. For creepage, as already mentioned, you can also now directly distinguish different insulation classes. And for the boards, each board has an own context where we can now enter the inner and outer rules for the corresponding board. And for the third board, we see that there are already values. They come from this MTX file I have chosen in the wizard. So normally you don't even have to enter them manually. They are already defined in most cases. So after we have defined our requirements, we can compute it. This would take a few minutes here, but I have prepared it, of course. And then we get a result which holds everything in one analysis. Again, we can switch the context here, so we can have a look into the mechanical context, or we can all see everything at once. So we see all the violations now between HV plus and the corresponding target. And per default, we show all the paths directly in the 3D window with a thin line. And then we can pick them directly here. Previously, you would have to go through this list, and if you see a certain path and you want to know, oh, this is interesting, which of these paths is it? That was cumbersome. You would have to go through them manually. No, now you can just click on them here, and then you see the details about it. Now we can have a look into this result. Here, for example, we have paths which go over different layers. It starts here at the top and then it goes around the board into the inside. And we recognize that this path is an outer path, so it needs the 2.5 millimeters. However, again, we could improve this by checking the segment. If this segment, for example, which is interior, the dashed line here, if this would fulfill the inner rule, which is 1.5 millimeter, then the path would also be okay. But this segment-wise interpretation, as mentioned before, this will come in one of the next versions. And now let's have a look. For example, here there is here's a path which is an outer path. This is on the outer layer of the board, so it requires a 2.5 millimeter. And just next to it, we have a path which is requiring 5 millimeters because it leaves the board here. It can apply the growth width, which is 1.5 millimeter in this case, so it can jump from the board to this pin, and therefore it's not a pure PCB path anymore. Therefore it needs to fulfill the mechanical rule. And other results like this, for example, are pure mechanical paths. And here are the paths which are, here's an example of a path which is going from the mechanics, from this bus bar, into a signal of the board, and in this case into an inner signal. You see it with the dashed line that that it's hidden. If we keep on hiding the parts here, now you can see the layer. And yeah, here we have also a very interesting path which is actually on 3 different segments. This path is starting here in an inner layer. It goes to the outside of the board on the top surface, and then it jumps to this clamp here, which is a potential free element. The current can go through this for free, and then it can leave it again here, and then it goes into the signal. So a very, very complex path, which is very, very hard to recognize without a tool like this. So basically that's it from my side. We have plenty of questions. So let me switch back to this, and now let's start the Q&A. I think, Urs, you will take over and collect the questions from the participants.
Thanks so far from your side. It was very interesting. At the moment there are no questions available right now, so again, please feel free to ask for questions. Use the question panel. Due to the big number of participants, we cannot unmute all of you. So we are waiting a little bit. Maybe from my side a question. What do you think, when will be the release available? I think that it will be a question from somebody.
Yeah, that's a good question. We will release a beta version of the 3.0 already by the end of this year. This version will be can be used for productive use already. So it's feature complete. It's not fully documented, but it's fully applicable already. The final release of the 3.0 is planned for March, April next year.
Okay.
But the beta version will have also an own update cycle. So it's already applicable. If there are still some bugs in it, then we can quickly fix them, and there will be updates also for the 3.0 beta version.
Okay, there is questions are coming in right now. One is about CCX. This is the tool in the integrated tool in Creo Parametric.
Yeah.
Is there a roadmap which shows the, let's say, the improvements in AutoCrear and in the version of CCX? So I think maybe the question is all the improvements of AutoCrear can we see them in CCX?
There is no way we can implement the ODB++ interface into CCX. It is just, we are just too limited, technically too limited by the API of Creo. As external developers for Creo tools, there's no possibility for us to bring this functionality into Creo.
Okay, that means all new functionality will never ever come into CCX.
Concerning the PCB interface in the different contexts, they won't be in CCX.
Okay, thanks for that interesting answer. Is it possible to install version 3.0 beta and a previous version side by side?
Yes. Yes. It's two.
That was a very short answer.
it's two separate programs. You can install them side by side, and they both work on the same license. So you don't even need a special license. Okay. If you have already a productive license of AutoCrear, it will also work for the 3.0 beta.
Okay, great. And another question is this PCB part, is that does it need a new license? Is this an extension? What is the cost of that extension about?
Yes, it will be an extension. It's for the first year, probably for the 2024, it will be included in the full version of AutoCrear, but yeah, it will be an extension. Not everyone needs it, probably. We also plan to make a version of AutoCrear which is an ECAD only version. So we have AutoCrear for ECAD, AutoCrear for MCAD, and then we have a combined version which can perform these combined analyses. So because of the new features, like for example conformal coating and so on, AutoCrear may also be very interesting for users who only have boards to check with these special features. So this is what we plan. We have an ECAD version, MCAD, also traditional AutoCrear for MCAD, and if you want to have both, there is of course a bundle of both interfaces. The cost for it is not fixed, but yeah, about 20 to 30% of the regular price of the AutoCrear will be for the ECAD extension.
Okay, that's starting in 2025, where the customer has to pay this additional cost.
Yes.
Okay, great. Then there are some special things showing the results just in one net. I don't know what this Ramazan is asking with that, showing the results just in one net. So I understand that you just say, okay, from that net, I just want to see that result. I think that's...
Yeah, I can imagine that the question refers to the restriction that we can only see a list between a net pair. You can you select a source net, then you have your target nets here. That's the same pattern we have here when we enter the requirements. We enter them for a net pair, and currently we have the same organization in the results. You choose a source net, and then you choose a target net, and then you see the result between the source and the target. We understood that this is a restriction which is not very popular. Many users want to see results independent of a source and target pair. They also want to filter the results in different ways. For example, only give me all the path in a certain region of my assembly, independent of source target pairs. This is something we are currently discussing, and we probably will do it in a way that there will be initially a global list of violations. There is no source selection, no target selection. There's just a global list of all violations in your analysis. And then you can make your own filters. You can still filter, okay, I only want to see the path from this source to this target, but you can also say, oh, I only want to see all paths on this board. I want to see all the paths which are involved a certain part of this part, for example. So there much more flexibility will be there.
Okay, thanks. So that's
I hope that was your question. I kind of just imagine that
no,
was.
but I think so.
Yeah.
I think this is answered. And I think we are more or less through the list. So are there any more questions out in the field? Wait, one is coming in. It's about CCX. Will there be any kind of development of CCX in further Creo version? Is CCX still supported in Creo 10, 11, 12, what else?
Yeah, CCX shares the core with AutoCrear. The computation of the paths is the same in AutoCrear as in CCX. When we improve our computations, the performance and the robustness of it, then they are automatically improved in CCX. So there will be new builds for CCX in the future. But the features, like this possibility to combine your mechanics with the boards, to enter different requirements for the boards and outside of the board, that's only in AutoCrear.
Yes, and also I think the result capabilities in AutoCrear will not be available in CCX.
Yes, we cannot influence the visibility of the paths in CCX. That's a PDC interface. So we cannot, for example, we have very nice features here to, for example, we can highlight a path so that we can see where it is. Or you also maybe know this path window which cuts a hole through the occluding of components. That's not very helpful here in the board context, but in a pure mechanical context, it's a very helpful feature to recognize paths very quickly, which are inside of the assembly. So all of these features for visualization, we don't have any influence on in CCX. And also remember the possibility to create a PDF report. That's also a very helpful feature. We can now generate a document from the results.
Which is also not available at all in CCX.
It's not available. We don't have the corresponding interfaces as external developers. There was no API functions which allow us to do that.
And I think that is a very, very important feature because within, let's say, 5 minutes, you can create a report of your results.
Yes. Here's an example of it. So that's a fully automatically generated report where you have everything documented you have done so far. You have a summary of your analysis and you have a detailed representation of your clearance and creepage paths. And this can be done with one click in AutoCrear, but in Creo we cannot do this. It's not possible. So as I said, I think CCX is okay for quick analysis on single parts or small assemblies, but for an entire system which we want to document very well, AutoCrear is the much stronger tool.
Much better, yes.
Yeah, I mean, it's the interface of Creo is made for modeling, and now we want to do an analysis for clearance and creepage. And all the interaction between the features we need, like electric net definition and so on, the interaction with the 3D window is optimized in AutoCrear. We have a 3D interface which we could tailor-made for this clearance and creepage analysis, where in CCX we had to use the modeling interface for the simulation, and this is very cumbersome. That's not very convenient.
Yeah, I agree. Yeah, thanks for that answer. And in my opinion, I mean, the learning curve for AutoCrear, this is very steep. So it takes maybe half a day, and then you're able to use AutoCrear. So it's really a very good interface, and it's quite easy to handle. And it never crashes. So I've never had a crash with AutoCrear. I don't know how they are doing that.
Yeah, lucky you.
Right.
That's I wouldn't sign that.
Okay, well, okay, you are the development, but for me, it's really very stable. This version.
It crashes like any other program in the CAD
but
world.
Not that often. Okay. So I think we are coming to the end. If you have any additional questions, I think you can show the last slide, Michael. If you have any additional, no problem. If you have any additional questions, do not hesitate contacting us, send us a mail. And I think we'd like to thank you for your time. I hope it was interesting for you. And in addition to that, I really want to thank Michael for his excellent presentation and for the information directly, let's say, from the heart of the development. And I think it was very interesting. So thanks a lot for everybody. Have a good time. And if there are any questions, do not hesitate contacting us. It was a pleasure for us. See you soon. Bye.
Yeah, see you soon. Bye.
Thanks a lot, Michael. Bye.